In this video, we're going to discuss the fundamental theorem of algebra and a polynomial of degree positive n. So if the highest exponent is a positive value, then we've got at least one complex number that will be a root or a factor. And we'll have a total of n solutions. N is the highest exponent, assuming it's positive. Those solutions may repeat themselves, so you could have an x plus 2 and another x plus 2, for instance. And you could even have 3. And that exponent also is an indicator of the number of zeros, or x-intercepts, where we cross the x-axis. And again, so if you have a degree of 5, fifth degree polynomial, you would have 5 possible solutions for f of x equals 0, and you would have 5 possible crossings of the x-intercept. But again, those could repeat themselves. It could be the same crossing. So, okay, these are the 3 basic things that make up the fundamental theorem of algebra. Now let's take an example. Alright, so if we have f of x equals x cubed minus 3x squared plus 9x minus 27, and so let's say the f of x equals 0. So the fundamental theorem of algebra, the highest exponent is 3, so n equals 3, which is a positive value. So that tells us that there's at least one complex factor. It tells us that there are 3 solutions, which may or may not be repetitious, and it tells us that there are 3 zeros. Let's take another example. We have function of x equals x to the 4th plus 6x cubed minus 32x. So we look at that, and the first thing we see is that 4 is the highest exponent, so it's a 4th degree. So n is equal to 4. So that tells us that there are 4 solutions for x, and it tells us that there are 4 x-intercepts, or 4 zeros, for that polynomial function.